Wilpinjong coal mine uses dozers to remove overburden and in 2015 implemented a semi-autonomous dozer program to improve the efficiency of this process. The semi-autonomous tractor system, or SATS, consists of 4 modified dozers which can be operated remotely or in a semi-autonomous state by an operator in the control station. On the 27th of May 2019, an operator returned to an excavator after being on break. The excavator was being used to scale a section of a high wall at the rear of the operating area of the semi-autonomous dozer fleet. The excavator was working behind a windrow which stopped midway along the dozer operating area. Earlier in the shift, a small bund had been constructed between the windrow and the high wall as a barrier to the work area. Throughout the shift, the dozers had driven through this bund and it had been leveled. At about 1:40 p.m., the excavator operator traveled past the leveled windrow into the active work slot of a dozer. As the dozer had completed a push, it started reversing. The dozer was traveling in second gear at approximately 7 kilometers per hour. As it got to the end of the slot, it collided with the rear of the excavator. The dozer pushed the excavator approximately 1.5 meters sideways. The excavator operator attempted to call the SATS operator on the radio to stop the dozer. He was unsuccessful. 5 seconds after losing traction, the system identified that it had experienced track slip and stopped tramming. From initial contact to the dozer stopping took approximately 14 seconds. An emergency response was activated. The excavator operator was not injured. The investigation into the incident identified the following causal factors. The controls implemented were found to be unreliable and prone to human error, such as the separation bund. There was a lack of engineering controls such as proximity awareness to allow detection of manned excavators by the SATS system and SATS operator. There was a lack of engineering controls such as collision avoidance systems to prevent collisions between manned and autonomous equipment. The height of the windrow prevented the excavator operator sighting the SATS dozers in the work area. The communication between the excavator operator and the SATS operator did not clearly identify the work areas of the SATS dozers. The bund used to separate the work areas was not maintained and became ineffective. Following the incident, the mine operator fitted a proximity awareness system to their excavators. The proximity awareness system allows the SATS dozers and operators to monitor machines and apply 2 virtual barriers. When the first barrier is breached, it triggers an alarm. When the second barrier is breached, the dozer stops, preventing a collision. The mine operator fitted an autonomous stop system to their excavators. Should all else fail, this system allows the excavator operator to remotely stop all SATS dozer operations from the cabin of the excavator. The mine operator requires workers to carry a portable autonomous stop device when entering the autonomous operations area on foot. The mine operator also implemented procedural changes that included creating guidelines for workers in the SATS operation area, defining minimum separation distances between manned equipment and SATS dozers, creating a process for the testing and allocation of A-stop devices. For more information and to see the full report, visit our website.